9:01, so let's get started, guys. Good morning, and thanks for joining EliteCISOs bi-monthly webinar. That's what we call EliteKnowledge session. So instead of doing 4 webinars in a month, we are doing 2 webinars now because we are doing a lot of physical events. So it's not possible to focus on 4 webinars as well as physical events. So this is our first webinar for October, and as you see on the screen, the title for today's topic that we are going to talk is the top 5 risks in cloud native development. So this very interesting topic will be presented by Mr. Rakesh Singh. Rakesh is cloud security architect at Palo Alto Network. So Rakesh will get about 45-50 minutes to talk about his session. And as I pass on to Rakesh, he will also do his longer introduction. And as you see, my camera is not on today. Rakesh, maybe you can turn on your cam. I'm in a low bandwidth area. I'm presenting from a very nice backdrop of Srinagar. So it's a great view out here, but the bandwidth is little low, so my camera will be off. From the agenda perspective, what you see is that 11 to 11:05, we will have a quick introduction. That's how we start. And then we will have about 45 minutes for the session. And then at the end, we will save about 10 minutes for Q&A. We will do our Wheel of Fortune, and the giveaway is a nice soundbar. And apart from that, as you know, we always give this challenge, which is called stand and attend. So even though my camera is not on, but I'm still standing. What you see on the screen is on the left-hand side, if you sit for the entire day, or if you are sitting while you are working or while you are in office, you might have all these problems which are shown here. But what we do is we give this challenge that for at least 1 hour when you are participating in this webinar, why don't you stand, right? If you stand, you will have all these benefits. On the right hand side, I think everybody has seen this slide a million times before, and I don't shy away from showing it again and again because of the benefits that we get. So go ahead, guys, put in the chat if you accept this challenge of standing for next 1 hour while Rakesh is going to present. So with this, let me transfer it over to Rakesh. So Rakesh, you are on. Go ahead, share your slides, and I'm going to stop sharing mine.
Thank you so much, Vikas. Let me share my screen. Team, if you can confirm, things are looking good to you guys.
Yep, sounds good. Screen is visible. Go ahead, please.
Thank you so much, Vikas. Good morning, everyone, and welcome. Thanks for joining me today in today's topic, where we discuss the findings, top 5 cloud native risk. I'm Rakesh, based out of Bangalore. I'm a cloud security consultant, specifically cloud native security consultant. For about 3.5 years, I've been working with Palo Alto, working with this technology. Right at the start of the journey, we have seen the whole market evolve, and there is a huge mind share about doing something natively in the cloud, not using the traditional solutions in the cloud, and that's what I've been helping customer with. Today's topic agenda is quite small. We will discuss about a few of the 5 key findings that we found when we worked with the team, survey with the teams like you. And we will discuss some of the best practices, and maybe we can have a question answer session after that. So before we go into the actual findings, the cloud story, if you see, this is really a story of 2 paradigm shift coming into alignment, the cloud and the pandemic. The cloud changed the game for everybody, and so did the pandemic. The pandemic, along with the subsequent upheavals that we have seen, not to mention the increasingly remote mobile workflow, turbo boosted the enormous cloud rapid adoption of cloud technologies. Who would have thought that India will be one of the largest, fastest moving market in the cloud? And we were very eagerly adopting this because we had very restrictive work from home regimes, and the whole development cycle moved to the cloud. Developer-led organizations are now innovating more rapidly and independently than ever before as they build new products and services directly in the cloud with hyper-competitive market conditions that exist in India. Today, nearly 70% of the organizations host more than half of their workload in the cloud. This is up from 30% in 2020 when we last did the survey. And yet, Gartner says that 50% of the organizations indicate a lack of internal knowledge about cloud native security. Most of the teams are still thinking of security in the old terms, and they're trying to adopt it to the cloud, which seems to be introducing a new set of risks. These four set of risks were highlighted by Gartner some time back, but we wanted to convert that into something substantial, that how are these problems manifesting. And the reason for that is when you go to the cloud at a fast track mode, there are dangerous pothole, and it grows larger the longer we ignore it. So we need to focus on the cloud native development cycle. We cannot be trying to do security post facto, where things are deployed, application has been deployed, tested. Now, just before going live, the security team comes into play. CISO teams are asked to basically give a risk sign off on the applications. That's not how things can scale up in the cloud. So the good news is that whenever you are on a right journey, with the right guidance, you can confidently steer the challenges. And we are seeing that even the banks, the top banks of the country, are now gaining confidence with all the best practices around cloud, and they are beginning to also adopt cloud. I would have thought that bank will be readily adopting the cloud, and that seems to be changing over here. So in our research, we regularly engage with and interview professionals in security, DevOps, technology, and line of business leadership in many industries. And with their input, we have identified the top 5 risks facing organizations as they are adopting cloud native approaches to the application development and deployment. Give me a second. Yeah. In this report, later I will show you where to get this report from. But in this report, we start with a baseline level of cloud native terminologies and terms that we are going to use, with answers such as basic questions. What makes an application cloud native anyway? This itself can be a large topic. I can spend the whole session talking about it. And but the basic idea that the consensus that seems to be emerging is there are 3 talking points when it comes to the cloud native application, which is the cloud native applications are containerized. They are dynamically managed, scale up, scale down, and stuff like that, and they are microservices oriented. An example of a cloud native application in action is basically, you can take Netflix. When Netflix pivoted from a DVD by mail company to the world's largest on-demand content service provider practically overnight, it was because they shifted their entire architecture from a monolith to microservices. This removed the blockers that historically stood between developing and testing new features and deploying them to the production. And in the case of Netflix, doing all this behind the scene engineering with no interruption to your streaming experience. So yeah, that's primarily the new applications development cycle looks like. These are the new technologies for newer applications. When it is being written, this is the widely adopted way of doing it. So let's go into the actual findings that I have been talking about. So the first risk, I think we all understand that application vulnerability has been there for all time, and we have lots of practices around it. And we have been, we also know that not everything can be solved in the vulnerability world most of the time. That's why there are additional guardrails that you put into place for exploit of those CV. But the problem in the cloud native world is compounded because today most of the code is not written, it is compiled. That is, today 80% of the code is basically open source. Most of the developers will start with some open source framework. There is, let's say, Nginx, Java framework with all these stacks pre-built. They take it and they do a development on top of it. So 80% of the code is basically open source. In this case, there is a problem that SAST kind of tools, which we have traditionally relied on, is not going to be enough. SAST can help you find the problems in the 20% area, but the 80% is not 100% addressed by using traditional vulnerability assessment tool or the SAST kind of tooling. The reason is when you compile this code, your 20% code is combined with the open source software, and how can you be sure this the 80% software that is coming in that doesn't have image poisoning? That means the binaries that the developers end up pulling into the image or container is actually modified, or basically somebody has poisoned those and the hash is different, isn't it? So relying on the traditional solution is no longer working, because once you can pull the software from the internet, the validity or the authenticity of that also comes into question, and that needs to be taken care of. The other part is the infrastructure misconfiguration. Remember, once upon a time, the entry into your cloud and application was via the firewall, which was the entry point for most of the things. But today, it is very much easy for anyone by mistake or by malicious intent to expose these services directly to the internet. It's just a couple of clicks on the AWS, Azure, GCP, or Oracle cloud environment, isn't it? So misconfigurations are the biggest problem in the cloud, and you cannot do, let's say, an assessment when the application is going to go live and assume that things stay that way, because the things change dynamically in the cloud, and you don't even know that some configuration has been done. So how can you sign off on an infrastructure saying everything is secure, because within a minute of you signing off, the things can change. So there are thought process that how to make sure that the configuration is always consistent. There is a continuous assessment being done, not when the application is going down or when the audit cycle comes into play. That's the important consideration that people are working about. The other favorite traditional being malware perspective, but malware used to be prevalent on the end user side, but now they are also getting prevalent on the server side, especially the new way of basically cryptojacking, which has been popular. Hopefully with the crypto market going down a bit, this will change a bit, but that continues to be a big problem where people are basically pulling software, or basically once someone gets a backdoor access to one of the environments, they are pulling crypto miner containers into your and running it. But by the way, this is not a theoretical exercise. I think 2 months back we had one customer in India where the tool alerted that there are about 600 containers that were launched in the background for about 3-4 hours in the night. Next day morning, when the team came up, nothing was running, so they were all shut down. The tool detected it and raised an alert, and basically the customer team came back to us saying, if the tool had not been there to detect such a thing, we would not have known about this till the bill comes, because when the bill comes, we will know that something was happening there. But the fact that you were able to detect it early so that we can stop the further exploit of those things, that's very important over here. So this basically, the containerization and other stuff is also helping people bypass lots of your traditional security measures in place. The other problem in the cloud, as we can expect, because remember we were talking about the firewall being the boundary that used to be there in the traditional data center, but in the new data center or in the new public cloud, then the additional boundary is basically the identity. Identity becomes the new place to start securing stuff, and there is a constant problem of keys getting lost or somebody getting an access, and that is always evolving, that we are always tracking using whatever endpoint solutions and spam filter and all those things that we think of. But the problem is compounded by the overprivileged accesses, because most of the time in the cloud, it is easy to give access more and more, but very difficult to take away the access. So there needs to be a mechanism to figure out what is the level of access that each user has and how many of them they are actually using. So there should be a mechanism to basically observe and learn that, let's say Rakesh as a user in the AWS environment has got 100 privileges that I can do, but in the past 3 months, let's say, or 6 months, I have used only 20% of them. There should be a mechanism to figure out the actual usage and continuously right size those permissions, and that's a difficult task to do manually or by any traditional way of doing stuff, isn't it? So overprivileged access is one of the biggest problems that most of the team is focusing towards, because yeah, vulnerability and all cannot be fixed, but at least this might be a better way of trying to work towards it. The other is insecure APIs. What happens is traditionally you have a perimeter solutions like WAF and all those things that were focused on exploit, CVE exploit and stuff like that. That is one way of obviously abusing your application and trying to do something bad with it. The other is trying to extract data from your environment and take it out, and it's very easy. At least the basic things are very easy. Go to any web page, do a right click and just inspect the elements of the page. You can see that in the backend that page is calling so many APIs in the backend, isn't it? So if those APIs access is not hardened, you will basically have this problem coming in again and again. But where do you harden those API access? Because WAF, traditional perimeter, is basically focused on malware and CV exploit prevention, monitoring, and how do you know what APIs needs to be allowed, not allowed? Because that's normally the task of the developers, and developer hopefully has done all the task, or normally in the initial stages they will have lots of open access and they might forget to turn those off. So that's a big security risk that is evolving over there, where the from the valid web pages, people can try out various combinations of the API and try to pull out data over there. These are all grim scenarios, and if you see the coverage of the problems in the cloud is quite vast. Each of the 5 things that we talked about, it's a totally different technology area sometimes, isn't it? So normally, what can you do over here? Okay, now that we have called out the risk, our customers have all the information to rethink their entire approach, isn't it? You can basically solve the problem. That's not so easy, isn't most of the time. The security risks are just one half of the challenges organizations face in the cloud native era. The biggest challenge is to overcome a culture one, and there definitely is no effective point solution for the shifting left security. Shifting left security is, you cannot do a post facto once the application is just about to go live. You need to work with the developers while they are developing things so that everything is secure. The truth is, the cloud and the cloud native technologies have given development teams autonomy for each services to be deployed, rebuild, redeployed, and managed independently across the software development lifecycle. Furthermore, breaking down of the organization silos in order to build common operating models between IT operations and DevOps. Basically, the traditional development team, IT team are basically getting merged, or there is a need for someone called as DevOps or Cloud Ops, who can basically, he travels both the world, and he might not be from security background, isn't it? Do your traditional IT guys at least had a security expertise that come into play? In many cases, this evolution happens while security was probably drowning in alerts. So security team is focusing on the alerts that are coming in. They're trying to fix things while they are not able to fix during the development time, they are not available. So when the application is about to go live, they again get bombarded with so many problems that they need to solve. And now they are perceived as the guys who always say, no, you have not done this. No, I have not done this. So how can organizations begin the process of integrating security? So most of these hygiene problems can be solved very early on in the cycle. Okay, so best practices are a good way to start. So let's start with the first best practice. I think this is very obvious from the discussions or the topic that we were discussing, is shifting the shift from the traditional structure to DevOps basically has unified the operations and engineering teams. Now, basically, this is the right place to start introducing security in that. So from DevOps, it should become a DevSecOps. It is crucial that the security architect, cybersecurity professionals work with the developers to understand what are the controls. Lots of the time, developers basically are given a list of Excel sheet that they are supposed to work with, but they might not be have that kind of bandwidth to work with that. So there needs to be a way to collaborate with them early on, so that they understand that the quality of the code that they're writing is ultimately dependent or is going to be affected if they are not embedding security. So wherever they are doing development, the information needs to come over there, but the security policies has to be governed centrally. You cannot let everyone decide their own security policy. The collaboration is basically to make sure that the centralized security policy that you have decided, or the guidelines or guardrails that you decide, everyone is able to adhere to that and they understand the limitations or the restrictions that is going to be allowed. The other thing is the consolidation. So most organizations have dozens, if not hundreds of applications and platform in the cloud that they are using to run their business, and most are now beginning to be cloud native. Most platforms in the cloud, they have good cloud native security tools from Microsoft, Azure, Google, AWS, Oracle. They all have a decent starting point of security tools. The problem is it's very difficult, and normally those security tools are accessible again to the DevOps team. CISO team and security team, even if they have access, they don't know where to get started. So it's impossible to use the cloud native tool in large, complex, multi-cloud environments, and using one set of tools. So that's the time using a single set of tool to protect all these various cloud environments It will create predictability when there's an issue, and you can make changes in the policy from a central place. So there is a need to have that tooling which is independent of the cloud, because today your team might be very happy with Azure, tomorrow they might want to use some services in Google and maybe on AWS. In that place, you cannot start rebuilding the security practice again around it. So you need to have a central way of consolidating things. Also, this is the time you should consolidate the runtime security. That is when the application is running, the security team does lots of things, observations and things over here, vulnerability assessment, and then the pipeline. All those also needs to be consolidated. So basically DevSecOps will encompass the runtime security when the application is running, but also the development security. And remember, something called as new concept that is coming is in the admission control, that what is allowed to run in the production, that should be automated. You can basically, there should be automated way of saying, if these vulnerabilities are not solved, if this misconfigurations in the cloud is not solved, things will not be allowed to get deployed. You can't have an Excel sheet based evaluation before things are allowed to go into the productions. Those kind of things are beginning to come into play over here. The next is basically correlation. Correlation, I think I covered a bit while I was talking the previous slide. The idea is to use security tools designed for cloud native development. You cannot use the traditional tools that you were using, the traditional whatever security tools. In the on-prem world, we had lots of security tools, endpoint solutions, scanners, so many things that we were using. They typically don't work well with the container world, isn't it? Because remember, when the containers talk to each other, the traffic between that can't even be observed because the packet is not even created, isn't it? Because in a single VM, there can be 20, 30 containers, isn't it? So basically, there needs to be a way to use the correlate all this data which is happening in the development and the runtime, and basically bring it all together. So if you take an example, traditional SIM tools cannot identify or basically identity solution or encryption tool. They are not going to give you understanding of what's happening in the container environment, Kubernetes environment. So using tools that are cloud native to protect information in the cloud is basically important, because it correlates those multiple data from the right from OS level to other stuff, container level, brings it together as a single consolidated thing to work with. And I think as of now, you would have hinted that this would be the thing that it will come down to, because now the rate of development is changing. The developers want to make changes faster. You have to start automating security also. Basically, development process, so if you don't automate, things just tend to slip through the cracks, isn't it? So you cannot be using Excel sheet every time and trying to do evaluation. So if you automate the development infrastructure and infrastructure implementation, that is even the EC2, S3 bucket, even if they are deployed, that should be an automated way of doing security and deployment of that. The security testing of the application is something that needs to be also achieved from the quality perspective. And couple of reasons that you want to do this automation is there's always limited resource, and if you put the burden on the developers or the DevOps to execute this task manually, it's not going to happen. It's really time consuming, and people have very high level of stress to begin with in the cloud world, and this is basically going to cause lots of burnout, and that's the reason people don't like CISO teams, saying they are basically just bringing the problems, they're not helping us move faster and stuff. So the more you automate and you inject the cloud native security into the development environment and deployment environment, you will be able to protect information much more consistently across the environment. And obviously, while doing this, you are stressing the developers less, so they like you better over here. Give me a second. Yeah, okay. And then finally, having visibility across multi-cloud, that's one of the first problem, isn't it? When I work with any CISO teams, we have seen that the main problem is they don't really have visibility into the cloud. They are not 100% sure what services is running in which cloud and where to start about security. People have the traditional thing of, let me put a firewall, let me put an endpoint solution. By the way, Palo Alto offers all these solutions, but that still doesn't give you visibility because there are so many PaaS services that teams are using. And this is where unifying the visibility so that you have the unified policy in a single place is the way to start. If you use a solution which is specific to, let's say, containers, or specific to VMs, or specific to AWS, or specific to Azure, that again becomes a problem because you are not able to have that single. Let's say if some problem happens, a CISO team are the ones who are supposed to give a risk. What is the risk or what is the exposure. But for doing that, they cannot be going back to the developers and asking for information at the critical moment, because every developer is using their own way of doing things. And you need to have a tooling where you can bring all these developers and the cloud infrastructure together so that the information is readily available, so that you understand your risk exposure. And this is one of the main things. Visibility is the starting point for most of the cloud security that we are seeing over here. Okay. So I would leave you with a couple of things in the discussion that we had. If you don't remember anything, try to remember this summary. The first thing is that organizations have moved to the cloud, and as a consequence, DevOps has really become the focal point of the organization. The pipeline also has expanded significantly as a consequence. The attack surface of the enterprise has expanded significantly because your pipeline of the software is open source now, not just in-house. And managing and securing the software in the pipeline using cloud native technology is the ideal solution. Instead of trying to reuse the existing tool that you have been traditionally using, cloud native technologies allows you to protect the DevOps pipeline in a best of class way. Organizations are spending lots of money in moving to the cloud, but the fact that you are spending a lot of money doesn't necessarily mean that you are adopting the cloud successfully or protecting information successfully. You have to have a consistent process to do this. DevSecOps integration and security automation are key to achieving successful cloud adoption. We talk to our partners, and the feedback that they give us is using the right set of tools not only allows you to achieve cloud adoption successfully, but it allows you to protect the environment successfully. And traditionally, and finally, the last principle that I believe you will, I will leave it you is that minimizing the number of security vendors. This was always a bit of a problem in the traditional world, but in the cloud native world, basically the more vendors, the more moving parts that you have, more difficult to protect your environment. The complexity is the enemy of protecting information in the cloud, where agility is the key, where you can't just wait for 2-3 months to deploy things and see how it settles before you deploy the next thing, because things move. By the time you decide to, let's say, use containers, your team might decide to use, let's say, serverless, Lambda functions, those kind of technology. In that case, what happens? So while you will never get down to one vendor, reducing vendor to as few should be what you should be aiming for. And then having the smallest number of security tools to protect the environment is what you need to achieve, because the teams that are using it is multiple. So every time you introduce a new tool, you need to retrain multiple development teams, multiple DevOps team, and that can become a problem for them to adopt it. And then going beyond what is there in the slide, I would say that there's a lot of security organizations they don't communicate, or they have lost communication with their business or technology partners when they move to the cloud. And that's one of the things that we all need to focus. And when you want to have a communication, it's good to have that communication early. Make sure that you understand who's on the other side of the cloud, because in the cloud, detecting problems is not going to help you. You need to detect it very early during the development cycle, so that your cloud partners can fix it, developers can fix it, DevOps can fix it. So this is journey, and you don't achieve this overnight, but partnering with internal and external stakeholders, as always, which was the priority for the CISO team. Make sure they understand that you're approaching this with a win-win perspective, and that you're not forcing them to use Excel sheet is the most important thing that you need to think about in this scenario. That was a quick session, and what I would suggest is you can search for Palo Alto Network's top 5 cloud native risk, and you will be able to download this paper and have a good guiding principle. Remember this 4-5 topics that we talked about, the top 5 cloud native risk, and we discussed what are the approaches that people are adopting to solve it. And that's all I had planned to discuss today. I will leave it for open for questions. I would appreciate if you have, you can unmute a mic and ask questions. That will be a good way to get started.